Hello guys, welcome back to the channel Engineer Study. How many of you have experienced a feeling of electric shock while opening the door of your car or while coming in contact with a household appliances? Well, wasn't that scary experience? But why does that happen? Also, why don't we get similar experience when we contact with wooden or plastic material? It is because wood is an insulator while metal is a conductor. When we come in contact with a conductor, there occurs a flow of electrons from one body to another. This is the reason we experience a shock. Shock is basically a mini feeling of current passing through the body. Let us learn more about the conductors, insulators, semiconductors with energy level and energy band diagram. So let's start. First we see what are conductors. Conductors are the materials or substances which allow electricity to flow through them. They conduct electricity because they allow electrons to flow easily inside them from atom to atom. Also, conductors allow the transmission of heat or light from one source to another. Metals, human, earth and animals are all conductors. The human body is a good conductor. That's why we get electric shock. So it provides a resistance-free path for the current to flow from wire to body. Conductors have free electrons on its surface which allow current to pass through easily. This is the reason why conductors are able to conduct electricity. See, conductors are the materials from which the current can be passed. Okay, and here current can be passed because there are the free electrons are available. That's why. See now the examples of conductors. Materials such as silver is the best conductor of electricity, but it is costly and so we don't use silver in industries and transmission of electricity. Copper, brass, steel, gold and aluminium are good conductors of electricity. We use them in electric circuit and system in the form of wires. Mercury is an excellent liquid conductor. Thus, this material finds use in many instruments such as thermometer. Gases are not good conductors of electricity because the atoms are quite far away. Thus, they are unable to conduct electrons. See, in gases, molecules are away from each other. That's why there is not possible for electrons to travel from one atom to another. That's why their electricity can't be generated. See now the applications of conductors. Conductors are quite useful in many ways. They find use in many real-life applications such as mercury is a common material in thermometer to check the temperature of the body. Aluminium finds its use in making foils to store food. It is also used in the production of fry pans to store heat quickly. Iron is a common material used in vehicle engine manufacturing to conduct heat. The plate of iron is made up of steel to absorb heat briskly. Conductors find their use in car radiators to irradiate heat away from the engine. Now see the next material, insulators. Insulators are the materials or substances which resist or don't allow the current to flow through them. In insulators, current can't be flow. In general, they are solid in nature. Also, insulators are finding use in variety of systems. As they do not allow the flow of heat, the property which makes insulators different from conductors is its resistivity. Wood, cloth, glass, mica and quartz are some good examples of insulators. Insulators are also protectors. They give protection against heat, sound and of course passage of electricity. Furthermore, insulators don't have any free electrons. It is the main reason why they don't conduct electricity. In insulators, free electrons are not available. That's why their electricity can't be generated. And insulators are mainly used to avoid electricity conduction. Now see the examples of insulators. Glass is the best insulator as it has the highest resistivity. Plastic is a good insulator and it finds its use in making a number of things. Rubber is a common material used in making tires, fire-resistant cloths and slippers. This is because it is a very good insulator. Now see the most important material, that is semiconductor. A semiconductor is a substance whose resistivity and conductivity lies between conductors and insulators. That means what? Semiconductor can be used as an insulator and can be used as a conductor. Semiconductors have the resistivity which is less than insulators and more than conductors. And you can say semiconductors have the conductivity which is more than insulator and less than conductors. Semiconductors have negative temperature coefficient. Means what? The resistance in semiconductor increases as decrease in temperature and vice versa. The conducting properties of a semiconductor changes when a suitable metallic impurity is added to it, which is very important property. These are the semiconductor devices: op-amp, resistor, capacitor, transistor, diodes and ICs. Semiconductors can be classified into two types: intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor means pure semiconductors and extrinsic semiconductor mean impure semiconductors. In extrinsic semiconductor, we need to add some impurities to conduct. The impurities are of p-type impurity or n-type impurity. That means extrinsic semiconductor are of two types, p-type and n-type. And that point we will see in next video in detail. Now see the energy level of electrons. An energy level represents the three-dimensional space surrounding the nucleus where electrons are most likely to be. We know every atom has nucleus and electrons. Nucleus is at the center and electrons are surrounding the nucleus with some energy levels as seen in this diagram. See here, nucleus is present at the center and electrons are surrounding it with some energy levels. See, the first energy level is closest to the nucleus and second energy level is little farther away than the first and third is a little farther away than the second and so on. But remember, in first energy level has the lowest energy and at far away levels has highest energy and that electrons can move anywhere. Means the electrons present at the outermost shell can move anywhere and that calls valence electrons. Now see the energy bands. The molecules arrangement in solid, liquid and gases are not the same. In solids, they are arranged closely so that the electrons within the molecule's atom move into the neighboring atoms easily. In gases, molecules arrangement is not close, whereas in liquid it is moderate. Therefore, the electrons orbital partially cover when the atoms approach mutually. Due to the intermixing of atoms in solids instead of single energy levels, there will be bands of energy level form. This set of energy levels which are closely packed are called as energy bands. See actually what? Electrons have different energy levels and make the set of same energy level and forms the bands, that is energy band. The bands are inner bands, valence band and conduction band. Here valence band and conduction bands are very important and the gap between these two bands is called forbidden energy gap. So first we see valence band. The electrons that are present in the outermost shell are called as valence electrons. These valence electrons containing a series of energy levels forms an energy band which is called as valence band. The valence band is the band having the highest occupied energy. See, the electrons present in the valence band have the highest energy. Now see the conduction band. The valence electrons are attached loosely towards the nucleus at room temperature. Means there is no strong connection in between nucleus and valence electron. When apply some energy or heat, then some of the electrons from valence electron will leave the band freely. So these are called as free electrons because they flow towards the neighboring atoms. These free electrons will conduct the flow of current within a conductor which is known as conduction electrons. The band which includes electrons is named as conduction band and the occupied energy of this will be the less. Now understand, in valence band, valence electrons are present and it has the highest energy. When we apply some heat, then electrons travels from valence band to conduction band. Now see the forbidden gap. The gap between valence band and conduction band is called as forbidden energy gap. As the name implies, this band is the forbidden one without energy. Hence, no electron stays in this band. The valence electrons, while going to the conduction band, pass through this. Means what? The gap between valence band and conduction band is the forbidden energy gap. And there electrons are not present. This is just the gap. Okay. The electron just travel from this gap from valence band to conduction band. But electrons are not present here. The forbidden energy gap, if greater, means that the valence band electrons are tightly bound to the nucleus. Now, in order to push the electrons out of the valence band, some external energy is required which will be equal to the forbidden energy gap. Now see the energy band diagram. Here three bands are present: inner band, valence band and conduction band. Inner bands is closest to the nucleus and it's completely filled with electrons. Next is valence band which is far away from the nucleus and it's fully or partially filled with electrons. Next is the conduction band which is empty or partially filled. And this is the gap between valence band and conduction band, that is forbidden energy gap. The electrons can be travel from this gap, valence band to conduction band. Now see the energy band diagram for insulators. Insulators are such material in which the conduction cannot take place due to the large forbidden gap. The structure of energy bands in insulator is shown here. See, the forbidden energy gap in between the valence band and conduction band is very large. So, the electrons can't be travel from valence band to conduction band. Now see the some specifications in insulator with energy bands. See first, the forbidden energy gap is very large in insulators. Valence band electrons are bound tightly to atoms. The value of forbidden energy gap for an insulator will be of 10 electrovolt. For some insulators, as the temperature increases, they might show some conduction. The resistivity of an insulator will be in the order of 107 ohm meter. Now see the energy band diagram for semiconductors. Semiconductors are such materials in which the forbidden energy gap is very small and the conduction takes place if some external energy is applied. Examples of semiconductors are silicon and germanium. See the structure of energy bands in semiconductor. See here, the forbidden energy gap in between the valence band and conduction band is very small. So the electrons can be travel from valence band to conduction band easily. Now see some specification of semiconductors with respect to energy band. The forbidden energy gap is very small. The forbidden gap for germanium is 0.7 electrovolt, whereas for silicon is 1.1 electrovolt. That means what? It requires same energy to travel from valence band to conduction band. A semiconductor actually is neither an insulator nor a good conductor. As the temperature increases, the conductivity of a semiconductor increases and it becomes a conductor. When not any external energy is applied, then semiconductor is work as a insulator. The conductivity of a semiconductor will be in order of 102 mH. Now see the conductors with respect to energy band diagram. Conductors are such materials in which the forbidden gap disappears as the valence band and conduction band becomes very close that they overlap. Examples of conductors are copper and aluminium. Now see the structure of energy band diagram in conductors. See here, valence band and conduction bands are overlap and forbidden energy gap is not there. Now revise all materials in the form of comparison. See first, conductor. The definition of conductor is a material that allows electric current to pass through it very easily. Semiconductor materials have the conductivity in between conductors and insulators, and insulator materials that do not allow the electric current to pass through them. In conductor, forbidden energy gap is not present. Here, the conduction band and valence bands are overlap. In semiconductor, forbidden energy gap is very small. And in insulator, forbidden energy gap is very large. Now see the conductivity of conductor is high conductivity. In semiconductor, conductivity is intermediate, and in insulator, conductivity is very low. In conductor, the conduction is due to the free electrons. In semiconductor, conduction is due to the movement of both electrons and holes, and insulator, no conduction. The resistivity of conductor is very low and the resistivity of semiconductor is intermediate. Resistivity of insulator is very high. The temperature coefficient of resistivity in conductor is positive. In semiconductor, it's negative, and in insulator, it also negative. The valence electron in outermost shell of conductor is less than 4, and in semiconductor is 4, and in insulator is more than 4. The examples of a conductors are metals like silver, gold, copper, aluminium. The examples of semiconductors are silicon, germanium, gallium arsenide, etc. Examples of insulators are air, mica, glass, paper, wood, etc. If you understand these all materials, please like it, share it and subscribe it. In next video, we will see semiconductor material in details. Thank you for watching.